Name, Kelvin Patrick Slaughter. GTID 902-540-244. We'll be taking these problems out of the book Calculus when Several Variables, chapter exercises 3.6, problems 49 and 50. We'll begin with problem 49. Problem 49 asks us to find the places where the derivative of x, f prime of x, is equal to 0, where f prime of x is greater than 0, and where f prime of x is less than 0. Our function is f of x equals the sine of x plus the cosine of x. Okay, so we'll start off by finding the derivative of sine of x plus cosine of x. F prime of x equals cosine of x minus the sine of x. So you can see. Okay, so we're going to start with A, which asks us to find f prime of x as f prime of x, where that derivative equals 0. Okay, so f prime of x equals 0. Alright? Okay, so we set cosine of x minus sine of x equal to 0. Okay, and then we get cosine of x equal to sine of x there on the bottom of the right of the page. Okay, so as we see, cosine of x equals sine of x. Now, remember, any of your trigonometry, you should know values for which the sine of x equals cosine of x. That's pi over 4. Sine of pi over 4 is the square root of 2 over 2. And the cosine of pi over 4 is the square root of 2 divided by 2. Okay, so pi over 4. Are there other values on the unit circle? Yeah, right there. Big circle. Where that value is the same. Yes, we've got 5 pi over 4. 5 pi over 4, the value is the same. It's the square root of 2. Well, it's negative square root of 2 for the sine of x, and negative square root of 2 over 2. That's what I meant to say. For cosine of x. So they're both negative at that point. So they're the same. So we can see that at both of those values, cosine of x equals the sine of x. So that's our first answer to A. What values of x exist where the f prime of x, where the derivative of the function equals 0. So that's at x equals pi over 4 and at x equals 5 pi over 4. Okay. Now, instead of trying to use algebra to try to figure out where f prime of x is greater than 0 and where f prime of x is less than 0, we're going to use a number line which will tell us everything we need to know. There's your number line right there. Okay, so we want to have these values. So we want to know values where x is positive and x is negative. So we have 3 intervals that we need to check. We've got 0 to pi over 4, pi over 4 to 5 pi over 4, and 5 pi over 4 to 2 pi. Okay, so here we go. We'll begin with finding a value between 0 and pi over 4. That's our first interval. Our point is pi over 6, because that falls between 0 and pi over 4. We know the cosine and the sine of pi over 6. So our derivative, f prime of x, equals cosine of x minus sine of x. So the cosine of pi over 6 minus the sine of pi over 6, as you can see right there at the bottom, if you can see that. F prime of x equals cosine of pi over 6, which equals the square root of 3 over 2, minus the sine of pi over 6, which is 1/2, equals root 3 minus 1 all over 2. You know anything? Square root of 2 is greater than 1, so that over 2 is greater than 0. It is positive. So we move down here, we move to positive over that interval. That's one of our intervals. For B, which asks where f prime of x is greater than 0. So we've got f prime of x is greater than 0 on 0 to pi over 4. Okay, now we need this second interval, pi over 4 to 5 pi over 4, so we pick a value that's in between. That value is pi over 2. Pi over 2 sits up here on the unit circle. You know anything? Sine of x is the y values on the y-axis, and cosine of x is on the x-axis. Okay, so as you can see, the x point, cosine of x is 0. Okay, so cosine of x, let's go back now to our derivative. Cosine of x minus the sine of x. Cosine of pi over 2 minus sine of pi over 2. Cosine of pi over 2 is 0, and sine of pi over 2 is 1. So, as you can see right there, right there, f prime of x equals cosine of pi over 2, which is 0 minus the sine of pi over 2. 0 minus negative 1, minus 1, equals negative 1, which is clearly less than 0. So we see our interval here is negative. So that answer C, values for which f prime of x is less than 0. Okay, our last interval, it is positive. We want a value between 5 pi over 4 and 2 pi. That value is 11 pi over 6. So cosine of 11 pi over 6 is the square root of 3 over 2. Minus the sine of 11 pi over 6. 11 pi over 6 is negative 1/2. The square root of 3 over 2 minus the negative 1/2 is square root of 3 over 2 plus 1/2, which is definitely greater than 0. So our second interval for which f prime of x is greater than 0 is 5 pi over 4 to 2 pi. So as you can see here, f prime of x is greater than 0 on the interval 0 to pi over 4 and on the interval 5 pi over 4 to 2 pi. And f prime of x is less than 0 on the interval of pi over 4 to 5 pi over 4. As you can see here. Alright, so that answers number 49. Now we're going to go ahead and move on to number 53. Number 53 asks us to find the derivative of a function y equals the quantity of 1/2 times 1 minus u quantity to the 4th power. So you can see right there, where u equals the cosine of x and x equals to t. First, we're going to do the chain rule. The chain rule states right here that dy over dt, which is the derivative, equals dy over du times du over dx times dx over dt. Okay, so we have all those variables, y, u, x, and t. Okay, so what do? Y equals 1/2 times 1 minus u, quantity to the 4th power. So the derivative of that, dy equals 4 times the quantity of 1/2 times 1 minus u to the 3rd power times the derivative of the inside, which is negative 1/2 times the which is 1/2 times negative du. So negative 1/2 du. I move the du over by dividing because we're looking for dy over du. You see it all right there. Dy over du. So then you're left with dy over du equals 4 times quantity of 1/2 is 1 minus u to the 3rd power times negative 1/2. So then we're going to look for du by dx. Alright, what is u? U is cosine of x all the way up here. So the derivative of that, du equals the negative sine of x times dt, or dx rather. So then to get du over dx, we divide by dx. So du over dx equals the negative sine of x. Then we're going to move on to dx over dt. X equals 2t. So the derivative of that is dx equals 2 dt. Divide by dt, you get dx over dt equals 2. Well, let's multiply them all just like the formula says. Okay, so we have